Okay, so now let's talk about two definite integral problem. Okay, so look at the first one. Integral from 0 to 1, 2t cubed plus 1, and then multiply square root of t to the power 4 plus 2t and then dt. Okay, and take a look at inside of this radical. If you take the derivative, it's gonna give you 4t cubed plus 2, right? Well, there is also a t cubed there, so we can make some connections by, doing this simple calculation here. And okay, so we're gonna use the substitution method again. So set u equals t to the power 4 plus 2t, and correspondingly du is going to be 4t cubed plus 2 times dt. Okay. The difference between using the u substitution for one definite integral problem compared to indefinite is you need to do one more step. That is, you need to find the corresponding limits for the new integral in terms of u instead of t. So we can do this. When t equals 0 refers to this limit, and then u equals 0 to the power 4 plus 2 times 0, which is 0. Okay. When t equals 1, then u equals 1 to the power 4 plus 2 times 1. It gives us it's 3. Okay. So the new limit is going to be from 0 to 3. Okay. So with all of this, we can start to do our substitution, which is first of all, it's from 0 to 3 because everything gonna be in terms of u. Okay. And I have 2t cubed plus 1 dt here, but I know that du equals 4t cubed plus 2 dt. So if you do slightly modification, in other words, if you divide 2 on both sides, you got du over 2 equals 2t cubed plus 1 dt. That's exactly what we have here. So make this substitution. Square root of this part is square root of u, and then 2t cubed plus 1 dt is du over 2. Okay, so now the problem is very straightforward. Okay, so it becomes into, right? I bring this one over to out, rewrite square root of u to u to the power half, and then we can make this. Okay, so it turns out, guys, if you plug the 0 into it, it's gonna always 0. So and if you simplify all of this, so the bottom here is gonna be 3 over 2. And then you time a 2 because they're both on the denominator. So it's a 3. So you have 3. On the bottom, u to the power 3 over 2, evaluate between 0 and 3. So you substitute 3 inside of this. And then, so it's a 3 to the power of 3 half over 3. So it turns out, because and then it's minus 0, okay, if you plug 0 in. It turns out this gives you the 3 to the power half, or square root of 3. Okay, so that is the basic steps for solving this definite integral problem. So now let's look at another one here. Find the area of the region enclosed by the following function: y equals x, y equals 1, and y equals x square over 16. So if we draw this, okay, this is y equals 1. Pretty sure that this is going to be something like y over 16. Okay. And this is y equals 1. Okay. So the enclosed region, it should be this piece. Okay. So this is 1. This is y equals x. This is y equals x squared over 16. Okay. So we need to do a little bit more. First of all, I can find the coordinate of this, which gonna give us is 1 and 1. Okay. And we also need to find the coordinates for this point. And we need to solve y equals 1 and y equals x squared over 16. To solve it, turns out that x equals 4 and minus 4. Okay. It turns out we only, since this point is in the first quadrant, so we only take the positive one because the negative one refers to this. Okay. So the coordinate for this point is going to be 4, 1. Okay. All right. So that's the pre-setup. We need to figure out the, okay, this is area. Okay, the area of this region here, and so this problem, we gonna set up our area integral in terms of y instead of x, because let me explain a little bit here. Let me all into all. So the region, if we just zoom the region, what we are interested here. You see, if I construct my integral in terms of x, remember the area between the curves, it's the upper function minus the lower function. Okay. So if we want to do the integration with respect to x, we actually need to split our region into two pieces. Okay, into two pieces. Because this refers y equals x, this refers y equals 1, this refers to y equals x squared over 16. And as you can see that, you need to set up an integral from here, from 0 to this point, and then add another integral from this point to here. Why? Because from this pieces to this pieces, you will see that your upper function actually is changing. From here to here is y equals x. But starting from here, it becomes into y equals 1. Okay. So in other words, if you're going to use, set up your integral in terms of x, you need the summation of two integrals. Okay. And this is how to partition your interval. However, if we make our integration with respect to y, in other words, guys, if I rotate this, then it's going to become very straightforward. Keep in mind this is y, okay? This is x, because I just rotate this. Now, do you agree if we're doing the integration with respect to y, since it's so easy? Because this is my upper function, it's fixed, y equals x squared over 16. This is my lower function, right? This is y equals x. So you can see that moving from here to here, and as y changes from this to 1, the upper function and the lower function does not change. Okay, so that's why it's better and easier to set the integral in terms of y instead of x. Okay. Now, with that in mind, we can draw our integral. So from 0 to 1, that's the y, and I know it's dy. Okay. So for this part, this is y equals x squared over 16, and this is y equals x. You see the difference. Now if you want to make the difference of those two, which is exactly the difference of the x expression for those two functions. Okay, but I need to solve the x in terms of y for both. So to do that, since y equals x squared over 16, so if you solve for that, you're gonna get only, well, again, we're only focused on the first quadrant. So we only look at this piece. So that give us is x equals square root of 16y. Okay, so this part. And of course, we got this piece is easily. This is x equals y because y equals x. So the upper function is going to be square root of 16y. The lower function is going to be x equals y. So we're going to have it to square root of 16y minus y. And that's the setup for this area of this enclosed region. Okay, so the rest is just to evaluate this. This square root of 16, I can take it as 4. Square root of y is y to the power half minus y, and then dy. Okay, and I can find the antiderivative, which is 4 times y to the power half plus 1 over half plus 1, right? And then minus y squared over 2. Okay, and then of course from 0 to 1. It turns out that if you plug 0, this part is all 0. So all we need to do is to evaluate a 1. So that is 4 times, well, 1 over half plus 1, which is 3 over 2. Okay, and then minus 1 over 2. So this part is 4 times 1 over 3 over 2 is 4 times 2 over 3, right? Minus 1 over 2. And that's 8 over 3 minus 1 over 2. Well, you can let them to have the same denominator, which is 6. 16 over 6 minus 3 over 6. It turns out that our final answer is I'm out of space. Okay, let me put an error here. It's going to be 13 over 6. Okay, so that is the answer for this problem. And okay, so I'll stop here, and I'll see you in the next example.